Okay, jumping in with some real questions now. Question 3, getting up to grade A very, very quickly. The square root of 40. Study this one with me. Square root of 40. Well, you press equals, you've ruined it. You need to try and get a square number out of 40 and the remaining surd, which will be irrational. So 2 times 20 doesn't work because 20 is not a square number, and neither is 2. But 4 times 10 makes 40, so the square root of 4 times the square root of 10 will make the square root of 40. Okay, so I'll split up this horrible little surd thing, which I actually quite like, into a rational number, root 4 is 2, and an irrational number, the surd called root 10. So altogether, final answer, I've got 2 lots of root 10. I want you to be very careful with that. That is not the square root of 10 written with a tiny little 2 about there. It's 2 lots of the square root of 10, 2 root 10, and that's simplified. Simple reason, because that root 10 is a smaller number than the root 40. I've actually simplified it. Next one, let's go across the page. I've got the square root of 4 divided by 11. How would you simplify that? Answer is easily, because the square root of 4 is 2 and it's 2 over 11, and that's nothing to... Oh, wrong question. That's from the previous page. Never mind. Over to question B. 3B. Sorry, I just skipped a page. Square root of 90. Square root of 90. How are we going to break this up? Well, the only way to get a square number out of that is to go 9 times 10. So root 9 times root 10 makes root 90. The square root of 9 is 3. I've been reliably informed. Multiplied by the square root of 10, which you can't do because it's a surd, it's irrational. Final answer, I've got 3 root 10. And just to make absolutely sure you don't mess this up, it is not the cube root of 10, like you had a little 3 there. It is, in fact, 3 lots of root 10. So you've got to read it carefully, say it carefully, and do it carefully. Next one, 98. The square root of 98. Now, I happen to know 2 lots of 49 make 98, and please look, 49 is a lovely square number, so I can happily square root the 49, and I have to happily square root the 2. Now, you can't do anything with the root 2 because it is the tiniest surd on earth, but the square root of 49 is 7, therefore altogether the root 98 is 7 times the square root of 2. Not the 7th root of 2, but 7 times the root of 2, just as we have there. Alright, so that is that answer. What else looks quite nice? I think I'll try, I don't know, I'll try I. So this is 3i. We have the square root, square root of 3 multiplied by the square root of 27. It looks terrifying, doesn't it? Well, I could split this up into 3s and 9s, but I'd rather do this. Look at this, it's quite easy. Combine it together, I've got the square root of 81, and we all know the square root of 81 is 9. So that simplifies down to 9. Really, really easy. Let's just pick one of these then. Turn over the page, I think. I've got this one. It says that the square root of 20 plus the square root of 5. Now, that is not the square root of 25 because we're not multiplying, we are adding. I can't do anything with that root 5 because it's irrational, but I can split the root 20 into the square root of 4 multiplied by the square root of 5. And don't forget to add the square root of 5 later on. What is the square root of 4? 2 times the square root of 5 plus another root 5. Altogether, what have we got? 2 root 5s plus another root 5 gives us 3 root 5s. 3 times the square root of 5, and since all these steps are equal to each other, one follows on from the other, we're quite entitled to write down equals and be honest with that. Dead easy, isn't it? I fancy J, I just so do, so off I go. I've got 4 lots of root 3. I've got to multiply that by the square root of 6. Well, what have we got here then? I can't do anything with root 6. I cannot do anything with root 3. But I can say 4 times the square root of 18. Can you see that? 3 6s are 18. I've created one bigger surd out of the two of them. I can go further because if you look very carefully, I've got 4 times the square root of 2 times the square root of 9. Look, 2 9s make the 18. Root 2 times root 9 makes root 18. So I'll split it off, and I've conveniently acquired a nice rational number from an irrational root. So I've got square root 2 times 3. What have I got then? Root 9 is 3. I've got 4 times 3 is 12. I have got 12 lots of the square root of 2. 12 root 2. And I think that is charming. Anything else that looks challenging? I think I'll try n. That's the last one. LMN. Yeah, so if I can do this one, let's do an easier one first. I want to sort of land this on you. H. It looks quite long actually. I've got to simplify. Root 8 plus 3 lots of the square root of 2. Take away the square root of 50. I think this is harder than the one I was going to do before. Anyway, you can't do anything with the square root of 8, but you've got to break it up into the square root of 4 multiplied by the square root of 2. That's that one sorted. Then I can add on 3 lots of the square root of 2. Look, that's the hint there. Now, if I've got root 2 and root 2 there, I can assure you that we're going to use a root 2 for this one. Now, 2 times what makes 50? Well, that's 25. And look, how lovely. The square root of 25 is going to be 5. And don't forget to multiply by the remaining surd. Root 25 times root 2 is root 50. So what have I got? The square root of 4 is 2. So I've got 2 lots of the square root of 2. Plus I've got 3 lots of the square root of 2. That was given me in the original question. Take away 5 lots of the square root of 2. What have we got here? 2 plus 3 is 5. So I've got 5 root 2's. Take away 5 root 2's. Believe it or not, all this simplifies down to 0. And that's worthy of a little exclamation mark. Horrific, isn't it? Well, there you go. Told you these were really neat. I'm very fond of them. Now then, what about these horrible little things here? Alright, let's try this one. The square root of 27 divided by the square root of 3. Now, I can break this up for you if you want to, but I can see that I've actually got the square root of 27 divided by 3. What's 27 divided by 3? 9. And what is the square root of 9? 3. That's beautiful. I could have done it differently. I could have broken this up into 2 little surds, and I think I'll show you how that could have been done. So if I take this one, working down here now, square root 27 is like saying the square root of 3 multiplied by the square root of 9. Look, 9 is rational, root 3 is irrational, and I'm going to divide by the square root of 3. Let's take it further. I've got the square root of 3 times 3 divided by the square root of 3, and then I'm going to come along with my blue and cancel out these surds. Root 3 divided by root 3 is 1. What am I left with? I'm left with 3 on top. And look, got a 3 up there, and I've got, let's put it in yellow so it stands out in contrast, a 3 down there. So I've worked out the answer to root 27 over root 3, 2 different methods. Alright, turn over the page, and these are so worth one's attention. Right, this one looks scary, so I think I'll try it. I have got the square root of 88, and I've got to divide that by 2. That's clearly not a square number. So what we got there? 2 44s, 3 4 422s is no good. Well, let's try 422s and then go a little bit further. You don't have to get it right in one go, but I know the square root of 4 times the square root of 22 will in fact simplify the 88 down, the root 88 down rather. The square root of 4 of course is 2 times root 22 along with it, and divide it by 2. Take my blue and cancel out the 2 straight away, and I've got myself so far the square root of 22. And question is, can that go further? can I take this 22 and break it up? Well, that'll give me 2 11s, not very good. 3 doesn't go in, 4 doesn't go in, 5, 6, 7, 8, 9, 10, nothing goes in. The square root of 22 is absurd. I can't get a square number in it at all. Therefore, that is my final answer. The con is, if you're not careful, you might say, oh, root 88 divided by 2. The answer is the square root of 44. No. Look at it carefully. I've broken it up into two square roots, one of which is rational, one of which is irrational, and I've taken it as far as I can go. The answer is root 22. And I fancy the last one. I so fancy it, I'm going to give it its own page. And I'm going to stop after this and then pause for reflection. And there's a lot more of this to do. It's so high powered, I'm going to do a lot of it, I think. Alright, let's just go for green. Alright, what have I got here? I've got 3 lots of root 12, divided that by square root of 3. I can do this in a number of ways. I can take my 3 and call it 3 and multiply that by the root of 3 times the root of 4. I don't like that, it's not very visible. Alright, 3 times root 3 times root 4. That's all divided by root 3, okay? So straight away, I'm not going to play with this any further. I'm going to cancel my root 3's top and bottom. And upstairs, I've got 3 times the square root of 4, which is 2. Final answer, that is worth 6. Alright, here's another way I could have done it. I could have said 3, because of that one there, and root 12 over root 3 is like saying the square root of 4, because 12 divided by 4 is, because 12 divided by 3 is 4, so the square root of 12 divided by the square root of 3 is the square root of 4. Now, what is the square root of 4? 2. So I've got 3 times 2, remember, 3 root 4 means 3 times root 4 right there, and that will still give us 6, so they're both correct. I would definitely stop now because things are going to get a lot heavier.